Hey guys, this is Pavanesh here.
Last week, I came across an article that said that possibly life could exist in Venus. And ever since, it has been causing so much excitement. So, what happened was a group of top researchers from all over the world had published this paper in a famous journal called Nature Astronomy. And because we can't look directly at other planets to see if life exists there, what researchers do is they look for a chemical called biosignature, which may signal the presence of life. So, in this paper, they have described the discovery of one such biosignature chemical called phosphine in Venusian atmosphere. The reason this is significant because in Earth, naturally occurring phosphine has always been found to be generated by living organisms. So, what does it all mean? Does life really exist in Venus? And is phosphine good enough to suggest life exists? Let us find out by analyzing a number of research papers, including this week's paper that has created all this excitement. And to answer this question, let us take a fact based approach. First, let us list the extreme conditions in which life exists in Earth. Then, we will compare it with the available data from Venus, including from this week's paper, and hopefully by the end, we can deduce some answers. Let us get started. First, let us look at temperature and pressure. In Earth, we know microorganisms that live in super hot and acidic waters of Yellowstone National Park. The hot water basin we see here gets the beautiful color because of the presence of heat-loving bacteria. And according to this National Space Society website that describes the microorganisms that can survive in extreme condition, we have microbes that can survive in temperature as high as 113 degrees Celsius and as low as negative 18 degrees Celsius, as you can see here. And according to this 2016 paper, life can exist in deep oceans where they can survive almost 1000 times the atmospheric pressure. Now, if we look at Venus, the condition near the surface is extremely crazy. The temperature can be more than 400 degrees Celsius and the pressure can be more than 90 times what we experience in Earth now. But there is a specific region above the surface of Venus where the conditions are much better. At about 50 kilometers above Venusian surface, the temperature and pressure are very similar to what we feel in Earth. In fact, this NASA paper thinks this is the best place in Venus for colonization. So, if we consider just the temperature and pressure, this region definitely has the proper conditions for life to exist. But the problem with this region is it is extremely acidic. So next, let us look about acidic environment. This region in Venusian atmosphere has sulfuric acid droplets, which are much more acidic than what we find in Earth. But when we look in Earth, we know bacteria that can survive in acidic conditions. For example, we have bacteria that can survive hydrochloric acid found in human stomach, where the pH level can reach as low as 2. And according to the National Society website which we saw earlier, there are species that can survive in 0 pH conditions, including in sulfuric acid environment. Even though the conditions in Venus are much more acidic compared to what we see in Earth, it may be not so preposterous to claim life may exist there. Now, let us look for food, water and energy. For this, let us refer the 2018 paper we see here. The paper was authored by a number of people from around the world, including researchers from NASA, JPL and from India and Poland. So, this paper analyzes the data about chemicals and water present in Venusian atmosphere and then compares it with how microorganisms behave in Earth. In the end, they conclude that there is sufficient chemicals and water for microorganisms to survive based on a iron and sulfur centered metabolism. Now, let us look about the energy that these microorganisms may be using. For this, we need to understand a mysterious phenomena that has puzzled humans for the last 100 years. So what we see is something in the high altitude clouds of Venus absorb more than half of all the ultraviolet radiations from the sun that hits the Venus. This phenomenon is known as variable ultraviolet opacity. Just to get a better understanding of this concept, let us look at these images mentioned in the same 2018 paper. These images of Venus were taken under different frequencies and these were obtained by the Japanese spacecraft called Akatsuki. So, if we look at these highlighted images which are taken under ultraviolet frequencies, they exhibit contrast. That is, some regions are darker and some are lighter. But if you look at these images which are taken under higher frequencies, they don't have any contrast. So, something is absorbing the ultraviolet frequencies. That's why the darker and lighter contrast appear. The 2018 paper suggests that the reason of this ultraviolet absorption could be microorganisms using it for survival, just like how plants in Earth absorb sunlight for survival. Here, they compare it with different biological molecules that we see in Earth. As you can see here, these iron-sulfur based biological molecules have peak absorption around 250 to 400 nanometer of frequency. And if we compare this to the images of Venus which we saw earlier, the frequency are tantalizingly similar. So, even though we do not have proof of it, the data bears an uncanny resemblance of a possible life which absorbs this ultraviolet frequency and are based on a iron and sulfur based metabolism. So, let us mark it as theoretically possible. And last but not the least, let us analyze the presence of phosphine. So as I mentioned earlier, naturally occurring phosphine has always been associated with life in Earth. But what about other planets? For example, in Jupiter and Saturn, we have observed phosphine before. But according to Sarah Seeger, one of the lead author of last week's paper, the chemical reactions that produce phosphine in Jupiter and Saturn is not possible in Venus. To understand this, we need to know a little more about phosphine. Phosphine is basically a simple but toxic compound with 1 part of phosphorus and 3 parts of hydrogen. In Jupiter and Saturn, there is enough hydrogen and the pressure can be extremely high, and these conditions are suitable for phosphine generation. But in Venus, neither do we have hydrogen nor do we have the extreme pressure required. So this specific way of phosphine generation is definitely ruled out in Venus. Another possible chemical reaction that can produce phosphine is water reacting with phosphorus in alkaline condition. But as we saw earlier, the condition in Venusian atmosphere is extremely acidic, and nor do we have enough water, as only 0.002% of Venusian atmosphere is water vapor. In fact, the researchers of last week's paper went through a laborious task of analyzing all possible processes that can produce phosphine and found none of them could have happened in Venusian atmosphere. In the supplemental section of last week's paper that we see here, they have analyzed processes like lightning, meteor shower, volcanoes, and chemical processes and found none of these could have generated the amount of phosphine that was observed. And complementing this conclusion is a paper that was published earlier this year. The paper which we see here summarizes that any detectable phosphine found in the atmosphere of a rocky planet is a promising sign of life. So, analyzing this paper shows not only for Venus, but presence of phosphine in any rocky planet is a possible sign of life. However, I do want to mention that this paper was published by the same group of researchers that published last week's paper. But there are researchers who raise doubt about the origin of phosphine in Venus. According to Justin Filiberto, a planetary geochemist at the Lunar and Planetary Institute, the possible source of phosphine could be volcanoes. This paper that was published earlier this year by their team suggests that volcanoes are much more active in Venus than we had thought before. And based on this information, he says this could be the source of phosphine. To this, David Clements, who was one of the co-authors of last week's paper, says that they have considered the possibility of volcano and ruled it out. He says the explanation would have made sense only if Venus were at least 200 times as volcanically active as Earth. So, the presence of phosphine does point towards life. Okay. Now since we have all the data and hopefully a better understanding, it is time to draw a conclusion. So now if we look at this table, at least to me it does not look as crazy as before to say life could be in Venusian atmosphere. We have favorable conditions and promising signs for life to exist. But even after this publication, David Clements, one of the co-author of last week's paper, gives only 10% chance to possibility of life. This is because we have far less data about Venus compared to what we have from Mars and Moon. This is because the number of spacecraft that we have sent to Venus is far less. But this could definitely change soon, as we will be seeing as many as 4 missions to Venus in next 3 years. And as we speak, a space mission called BepiColombo, which is a joint mission between European Space Agency and Japanese Space Agency, is heading towards Venus. It will have a chance to take measurements twice in next 2 years, as it will be flying really close to Venus on its way to Mercury. But the next major mission that would be specifically studying Venus is by NASA, and it will be launched next year. Called Da Vinci Plus, it would be the first American spacecraft to enter Venusian atmosphere since 1978. We also have a private company called Rocket Labs, which is based in New Zealand and United States, is also planning to launch a small probe to Venus by 2023. And we do have the Indian Space Research Organization that will be launching its Venus mission called Shukrayan-1, with possibly 18 Indian instruments and 7 international instruments. And all these could be bringing valuable data that could shed more light about possible life in Venus. So, in conclusion, even though we are still far away from saying with certainty that life exists in Venus, we do have positive signs pointing to possible life there. And hopefully in next few years, we will have much more data and much better understanding of Venusian atmosphere. And possibly with this phosphine discovery, more countries will start focusing on Venus, and much more complex mission could happen in next few years. All in all, we have exciting times ahead, and after years of speculating and searching for life in faraway galaxies, we may very well end up finding it in our neighboring planet. That's really amazing. So, that's the end, and what do you all think about life in Venus? Please let me know in the comments. Alright guys, thank you for watching this video. And as I was researching about this video, I found some interesting papers about what scientists think about possible evolution of life in Venus, how it ended up from surface to Venusian atmosphere, and how their life cycle could be taking place today. And my next video will be on this topic, so do subscribe to my channel if you have not done yet.